Hello, everyone. Welcome back. I'm Ali. Joined here with Kartika, my amazing co-host as well. We're back for another Compute Over Data Working Group Live Jam, our third session now, and we're lucky enough to have the amazing Simon Worthington here with us. Hey, Simon, how you doing?
Hello, good, thanks. Good, both. How you doing?
Good. Tell us a bit about yourself. I know we've worked together before. Simon was actually instrumental in building out Lilypad version 0, which for those of you who might not know, was a bridge between the Filecoin virtual machine and the Bacalhau public network. So it allowed you to kind of call Bacalhau compute jobs from your FREM smart contracts, and you can still do that. So he was instrumental in helping me build that bridge, and I think learn a lot about Ethereum at the time. So, but what have you been up to otherwise, Simon?
Oh, well, sorry, what have I been up to otherwise?
What else have you been up to besides that?
I was laughing so hard at your joke, but I've been working on Bacalhau since then for Expanso. So we've been taking Bacalhau from the 1.0 release that we did in May and starting to add lots of new features that lots of people have been asking for, which I could talk about a bit more if you like. But some of them are things like custom executors, so you don't have to just build a Docker image. You can actually start from a higher place like Python or JavaScript or whatever and run that on Bacalhau directly.
Wait, JavaScript? That never had JavaScript capability.
No, it didn't, but it's coming. It's coming soon. What? Soon it will be there.
That's exciting. Now I'm interested.
Yeah, so that's coming. Also things like long-running jobs. So it's not just to kind of run a compute job and
time out
and wait for it to do, but actually kind of run a job that's continuous and streaming and like very, very long. So yeah, working on lots of those features, bringing Bacalhau to more people, all that good stuff, basically.
Awesome. And I think one of the reasons that we asked you to join us here today as well was, like, I know you're leading kind of that engineering effort on Bacalhau now. One of the things that was super interesting to me and to Kartika as well was your talk from the Compute Over Data Summit, where you released Bacalhau version 1, and you were talking all about federated learning there. And I think that was something that you really enjoyed as well, Kartika. Could you do you have any questions you wanted to ask about that talk there? And I'll find it and put it up on the screen for everyone as well.
Sure. Yeah, like super interesting. Like so, you know, we will go, like Simon will talk through a couple of, you know, like the latest developments, but I think later on we'll talk a bit of a case study. And I think what I love about these federated learning blocks would be for medical data and how we can really, you know, be able to answer some of the questions and how can I, you know, like basically ensure that my data is sort of safe, not being shared around in terms of being able to share data with people you might not trust that much, but still give access to it, you know, like that's one area like I quite thought was really interesting. And then considering that, like, I think 68% of enterprise data is not being, like, it's not really being used or like not being able to give access to. That's one of the things I quite like to explore a bit more. And then in terms of governance data as well, like so the government's 100% of data is governed under GDPR or HIPAA or FISMA or all of these other ones you mentioned in your talk, and David too. I think, yeah, super interesting to learn a little bit more about that. And we chatted a bit about the medical case study in terms of breast cancer or like medical data and how we could sort of like set this up. So yeah, super interesting to hear a bit more, but I'll let you talk a little bit more and give you an overview about Bacalhau first, and then we can sort of deep dive into these other questions.
Yeah, sure. Yeah, happy to talk a little bit about Bacalhau. So Bacalhau is a computer data platform. It's open source. It's on GitHub, github.com/Bacalhau-project. And what it aims to do is be a kind of commercial, off-the-shelf, like commodity platform for building compute over data networks of all sorts of different types. So we have like a kind of a global public network which you can join, and anyone can submit jobs to that network and have them run against like volunteer kind of compute that's out there in the world that's run the network. But but maybe more importantly, what you can do is download the software, run your own computer over data network with your own hardware, and your own environment. And what that allows you to do is take the kind of general Bacalhau architecture and apply it in lots of different interesting ways. And computing over federated data is exactly one of those ways. So yeah, since the 1.0 release, we've been working on a couple of things. I talked about the executors. I'll say a bit more about them when we come to the actual computer federated data bit. But we've also been working on long-running jobs. So this is allowing a job to exist for a long time, weeks, months, and continually receive new input, because lots of processes are not kind of run it once and then forget about it, but they're kind of more like it's going to receive new input over time, and you need to kind of react to that new input with some sort of operation. I mean, as an example, a key one might be like user presses a button and says something into a microphone, and then you need to then do text to speech and then apply it to a large language model. But you need to do that every single time the user presses that microphone. So it's less about kind of a one-off job. It's more about like a job that will get run multiple times under the same context, and often in quite constrained environments. So like one of the places that we think a lot of this stuff is going to get applied is actually on home devices. So like on your smart fridge or on your smart speaker. And it's also about kind of bringing computer over data jobs to those places as well, like that are reasonably constrained. I have also talked about running jobs on satellites in the past, which actually I think is something that is happening. I think we have I can't remember. I think we have a partner who's going to run some Bacalhau nodes on their satellites. I can't remember the details. And also, I'm not sure the details of it, so I probably shouldn't say anymore.
They did put IPS in space as well, so I could definitely see Bacalhau being useful up there. I mean, it running on IoT devices as well is another really cool feature about it. Yeah. Space. There we go.
yeah, that would be great, wouldn't it? And beyond that, we've just been working on things to make the system more reliable. So we've got a partner who loves to submit like 100,000 jobs at once. So that's been quite a learning curve of, okay, so you're going to have this big spike and then nothing. How does the system handle that? And so we've been putting in kind of persistent storage and load spike handling tech to make sure that if you submit 100,000 jobs, you get 100,000 results. Some of them don't just disappear and go into the bin or anything like that. So yeah, increasing the kind of quality of life, I suppose, has been a lot of what we're working on. And also experimenting with new ways to submit jobs. At the moment, the way that Bacalhau is very much designed around the public network. So it was like, here's a job, who's going to run it? And you might give it to one person to run and they'll come back. Or maybe you need 3 people to run it and they'll come back. But also what we see especially in these edge scenarios is I've got a whole fleet of, satellites, smart fridges, whatever. I want to run it on all of them. And so actually one of the things we've been doing is maybe it's possible to target an entire network or target an entire subset of a network, not just running the job, but actually running it everywhere that it needs to run. Kind of bringing a different dimension to what's possible as well.
Yeah, interesting. That's a really, like, say, a networking challenge for like almost LoRa, but everyone, you say LoRa, people think about AI, don't they?
You mean like LoRaWAN, the radio? Yeah. No, that's exactly the sort of thing. Yeah. Maybe you'd have some LoRaWAN sensors connected to a computer node, or maybe they would be computer nodes, but it's absolutely designed to work over those sorts of like very low bandwidth, like high latency connections.
Yeah, very cool. So lots happening then. We've got a free QA tester for scalability, it sounds like, there with the
which is really helpful.
That was. Gotta love your QA testers. Give me a badge. Thanks for helping with the QA.
Yeah, thanks very much for that. Oh, it would have been nice if we told us in advance, but
so how robust is the public network now, by the way? I've been working on Lilypad obviously for a while now. I transitioned from Bacalhau, and Bacalhau became an open source project, and I've transitioned to working more on Lilypad, so I haven't had as much to do with Bacalhau as I used to. So this is like really great to learn all the new things happening for me as well. And is the public network still running was my question. and how robust is it these days?
Yeah. Yes, it's definitely still running. We've still got a bunch of like compute nodes that are run by the Bacalhau team, and we've also got still got a bunch of volunteer nodes that are being contributed by people, some of whom we don't know who they are, but that's kind of the nature of having a network like this. When people come along, but I mean, the public network is deliberately limited because we don't know who's going to be submitting jobs to it as well. It's not just about like public compute nodes, it's also public users. It's deliberately limited. So there are lots of things you can't do on the public network that you can do in a private setting, like jobs can't access the internet. You can't have a job that lasts longer than about an hour. You can't use too many resources at once. You can't access like local file systems or anything like that. So it's really intended as a way for people to check it out, I suppose, like check Bacalhau, like as a demo, ultimately. See how it works. You know, happy to also support kind of people running jobs for public good on there, like absolutely no problem. But it's intentionally limited for security reasons and to protect the people who are providing their compute, including us.
Fair enough. So
yeah, where people have been coming up against those limits, we've been saying to them, oh, well, also, it's really easy to run a private network. Here's how you do it. I'm trying to make it as easy as possible to set up one of those things.
Yeah, that's awesome. So there's probably a pretty good how-to guide of how to set up your own private network now, I imagine, in the docs.
Yeah, there should be a good one. I mean, docs can always be improved. So please do try it out. And if it doesn't work, come into Slack and tell us that it doesn't work. But definitely keen for people to do that and for us to make it even easier. I mean, we'd really like to get to a place where it's kind of one-click setup or something. You know, maybe not one click, but one click per compute node. So it's just you just run it on the machines and they just all magically connect together. That's kind of the end goal for how easy it should be, I think.
Okay. So do you want to jump into the case study a little bit? Yeah. Just to bring like the technology a little bit more to life, also for the non-technical folks, I thought we go through the scenario. So let's say I want a private network and add all my medical data. As I said earlier, my dad is an oncologist, and wouldn't it be amazing that all the mammograms and like all this other data would be he could actually share, like first within universities, but then people can actually contribute to that as well. So that would be one question. So just how to set up the private network.
Yeah. Okay.
And then the second step would be like, so that people just understand the scope. We would then have like these federated learning blocks, people could add to those. And then eventually there could be federated machine learning and, like some jobs can be run. And then the nice thing would be people could actually get royalties at the end for, contributing the data. One thing we would like to ensure is that nobody can sort of tamper with the data and sort of de-anonymize it. I think, with row weight, being around now, people are much more aware and have to be quite careful in terms of, how data is being shared. So that would be sort of like the overall scenario.
Yeah. Okay. Yeah.
So in terms of the, setting up like a private network, how would I go about that?
So it should be super simple. And Ali linked to the docs on the comments. But broadly, all you need to do is download the Bacalhau software, and you have a command in that software, Bacalhau serve. When you do that, it will spin up a compute node. And what you ideally want is to make sure those compute nodes are next to the databases that you want people to be able to access or have access to that data. So there's lots of, as you imagine, there's lots of different like configuration options, but you can, for example, load it with credentials to access an S3 bucket, or load it with credentials to access like a Postgres database, or file share, or like a private IPFS network, any of those things. And yeah, to take advantage of the of the performance. You want to do it as close to where the data lives as possible. So you would stand up what's called a requester node, and the requester node is the thing that handles all requests from the users to actually run jobs. It is like a trusted agent of the user, but it's also a trusted agent of the network. So the requester node, as well as responding to user requests, is kind of responsible for moderating them as well. So you stand up that requester node, configure it appropriately, and then you connect into it all the different compute nodes that you want, attached to all the different databases that you want to make available. And then that's it. Ultimately, like, you only need to do those things, and then you've got a fully functional Bacalhau network, which can answer these sorts of requests. It's not like there are various like flags for controlling the privacy of stuff, but ultimately all you need to do is specify that the things that you're operating on are private. So you're not connecting to any kind of other Bacalhau network. You're not connecting to any other IPFS network. Nothing that you're doing is going to leave the confines of what you've configured. And then you can configure the like moderation options. So by default, the requester will send, well, by default, the requester will just allow all jobs to be used. So the way in which you would control that is by controlling the users who can access that requester node, like via like AWS credentials or G-Cloud credentials, or whatever you're running in your own data center by your kind of VPN credentials. That's quite a broad brush thing. So it's obviously like, you know, you let one person in and they can access everything the next person can, but actually sometimes what you want is different people to have different levels of access, or you want to be able to know, you want to know for audit purposes, like who's doing what. So Bacalhau has the concept of a client identifier. So every user has a unique client identifier associated with their machine. And you can collect those up and, you know, assign them to specific people, and then say to the requester node, actually only accept jobs from these client identifiers, or only accept jobs from these real world identities. Or you can go a bit even deeper than that and say, actually, this person should only be able to access this person should only be able to access that, blah, blah, blah. And you can get as specific as you want, ultimately. Like, there is a lot of control about how that requester node will accept jobs. There's also, you can get kind of into this middle ground. So you can say, you know, these users shouldn't have access, these users should have global access, but more realistically, most users can access all the things that we think are not particularly controversial. So if the user wants to access this data set, well, it's mainly public anyway, so they can just access it. But if users want to access this data set, it's sensitive, you know, maybe it's pseudo-anonymized, but it's still got quite high value data in there. So their jobs will need to be moderated by a human to check that what they're doing is kind of valuable. So one of the slides that I presented at the during the COD summit was on this. Let me see if I can find it. I can't. Not that one. This one. So the various ways in which people talk about like what is acceptable, and I guess the key elements that mean you need to have moderation are like, what people are going to do with the data is as important as who, and as important as what the data is. So, you know, you're obviously happy to share data to do with like mammograms for the purposes of curing cancer, but if someone came along and said, actually, I want to use this data to like increase the profits of my pharmaceutical company, maybe you would say, actually, no, I don't support that goal. Like, that's not in line with why I'm sharing this data in the first place. So I'm not happy with that. So understanding the context around what the job is going to do is kind of part of that moderation job. So yeah, you can configure ultimately quite a high level of with a high level of control what jobs should be run, and also pass it to a human moderator to say, you need to check this to see whether this is going to do something inappropriate or not. So the thing that's interesting about that is, at the moment, Bacalhau runs like Docker containers, or it runs WebAssembly. Moderating those is quite hard. Like, if someone says, I'm going to run a random Docker image over your sensitive data, I would be like, well, what's it going to do? Like, how do I know what's in the Docker image? And sure, you can inspect a Docker image and you can check it out, but like actually, that's very difficult to do, and it's a technical job. Like, you need to be a technology expert to know how to do that and to really assess it. So I talked earlier about pluggable execution, so bringing higher level languages like Python and JavaScript directly into Bacalhau, and this is one of the reasons why we want to do that, so that you could just submit a Python script to run against the data. Like, that can be significantly less complex than a Docker image, which is a lot easier to moderate. Or, for example, you can go even higher and just submit like an SQL query to run against a database. Quite easy to moderate compared to like a blob of WebAssembly, which is very difficult. So yeah, one of the reasons that we're doing that work is to kind of make it easier for people to moderate jobs in these private environments, I suppose.
And this sounds like a great challenge for like a hackathon or something, because I was looking into that, and I had exactly the same questions. I'm like, how can I know what, like, how can I quickly decide? And that person is pressing the button, like, yes or no. It's like no pressure.
Yeah.
How can you really evaluate, what's going to happen and what they're actually running? But yeah, perfect. Like, this sounds amazing that this is coming up. And I would love to like learn a little bit more and how people can actually use that and make it accessible, and then have like a great interface, around that. So yeah.
Yeah, definitely. I mean, that'd be a great hackathon topic. Like, we've kind of always imagined that there would be automated tools that can help with that moderation. Like, can you apply some AI to a piece of code or to a whole job and get it to generate like some level of risk, or to kind of try and describe what it's doing in a way that is helpful for a human moderator. And we've never really tried it. So that would be great to see people doing something like that.
Awesome. Yeah. Maybe something we should talk about with Ali. Put it together.
Definitely a big field, I think, going on there.
But
moderating content is hard, isn't it? Because I mean, it's always going to come down to, it depends who your community is and what you're trying to moderate. Like, some things are obvious and some things just really aren't. I don't know if anyone's heard of Blue Sky, the social media app, which is trying to kind of create this version of Twitter or X or whatever it is now. I just can't say X with a straight face. It's like, do you want to close your app? Why did you do that? That's close, you realize? Like, up the top right, press the X. Anyway, I digress. Anyway, so Blue Sky is kind of creating this version where you'll be able to bring, it's kind of like Mastodon as well, where you'll be able to bring your own servers, and then you as a community kind of decide what sort of moderation rules you want around that. And, this is only parallel, likely, in the same place here. But, I think content moderation is like one of the challenges that has just been a challenge for many years, and it's still like really unsolved. How do we do it well? And yeah, I think, there's lots of different ways to do it. I definitely think AI is going to be able to help, though. You're right about that answer.
Yeah,
no, it's definitely really hard. And I think you're absolutely right that the key is to understand, like, your community, or I guess in this context, like your topic and what the sort of risk factors are. Because right at the bottom of that list is safe outputs, which is exactly the same problem as content moderation, right? Like, you've got some data coming out, you need to moderate it as automatically as possible. And it's a lot easier if you know that, like, oh, we're working over patient data, and the big risk is people's details being leaked.
Yeah.
And actually, it's a lot easier to solve that problem than it is to solve like a general problem of, like, is this image offensive? And it's like, well, that's quite a complicated question.
Yeah, exactly right. And I think there's kind of a parallel here, or at least a random segue that I'm going to take into this. This is also the case with how we're building out, kind of this incentivization layer, which is Lilypad, which, is basically taking the Bacalhau public network and turning that into an incentivized version of that, or like a Web3 version of that. Like, so much like kind of Filecoin is to IPFS, you could say Lilypad is to Bacalhau. A lot of extra code going into this, but the basis of it was, the Bacalhau code and a paper called Modicum. But yeah, in much the same way, how do we know that nodes? How do we trust nodes to do the right jobs? Like, that is your safe outputs. And at the moment, the only way that we are able to test that is to make sure that our jobs are deterministic. But a lot of computer jobs aren't deterministic. So at some point, we are going to have to figure out how to run non-deterministic, to a certain degree, jobs on the network, and still have the ability for game theory to catch when nodes are doing the wrong thing. So really interesting research problems anyway.
Yeah, that's really interesting. Yeah, I mean, I think there is like interesting pedigree from people like Coy, who like sort of taken the problem and punted it, but in a quite interesting way, which was to say, actually, you're the one running the job, or you're the one running the community. It's up to you to decide how best to like decide whether or not the job's been done correctly. Because if you're screen scraping something, like, well, it can change, right, between results. So it's kind of statistically, is it better? So yeah, it just depends on the workload, which is quite hard to do generally. But lots of interesting research for sure.
Yeah, definitely. And I think Levi Rybolov, who's our researcher on this and knows way more than me. I'm just like kind of regurgitating some of the things I've heard from smarter people than me, basically. is actually knows Koya, has worked with him quite a bit. So you definitely see the parallel there as well.
If anyone can do it, Levi can. So
yeah, exactly. Brilliant brain there.
Another question was, I think we were looking at that in terms of, saving costs and sort of egress costs in terms of Bacalhau. And, you had like an interesting calculation. I was just wanted to highlight that a little bit again.
Yeah. So, I mean, this is a slide that's come out of Hilary, which is really like demonstrating the sort of the reason, like part of the reason why we like doing computer over data in place is valuable, because I mean, for example, this is the egress cost. There's a similar ingress cost, which actually I think is more than this as well. But ultimately, just the act of moving data around, it costs you money. Like to get data in and out of these big clouds like AWS and Azure and Google Cloud is costing people like thousands of dollars. 50 terabytes, like, I don't know whether people think that sounds like a lot anymore or not. Like when I had my first PC, that was like unfathomably large amount of data. But I think you don't have to go to very large scale anymore before that becomes like just a commonplace amount of data. I mean, like the amount of data that Netflix has, the amount of data that Amazon has is going to like outstrip that by orders of magnitude, right? Like several, in fact, orders of magnitude. So yeah, if you imagine the numbers in the kind of next to AWS, like 4,300, and just times it by like 100 or 1,000, and in fact, I think the costs do they're not linear either, I think, for these clouds. That's when you're starting to just see something that is just prohibitively expensive. And definitely the reckon from, I think, most computer over data platforms, but certainly Bacalhau in general, is that this is not affordable or sustainable ultimately. Like another one of my favorite stats is data growth. The growth of data volume is outstripping the growth of network bandwidth by like a factor of like 43%. So that just means that it's not going to be very long before we just physically cannot move all the data that we have around into a central place for it to be queried. When you look at these cost numbers as well, Like if your data is getting to be this scale, just kind of moving operational data in order to query it is just costing your company like thousands of dollars, hundreds of thousands of dollars annually. It's just a cost that if you want to be competitive, it's a cost that you won't have ultimately, because the only reason that you have it is because you're a little bit lazy and haven't thought about how to avoid it. And computer data is the answer to how you avoid that. And
also the time, right, required. I think one super interesting area would be to analyze, the sort of carbon footprint, the reduction you would actually save because of that. So that would be maybe like another hackathon or something, like just a research study in terms of, like net zero. There's a lot of criticism around that as well, but this would actually solve some of this.
Yeah. I mean, doing less ultimately is the answer, and moving data is one of those easy things to do less of if you have the ability to query it. And I think you're absolutely right that a lot of people don't appreciate how slow data transfer still is. I was reading, I can't remember where it was, but a news article the other day where they raced a 50 terabyte data transfer between like two European cities. One was over the internet and the other one was on a pigeon, and the pigeon got to the other data center like about 20 times faster than the internet transfer took. So I think that it's something like the internet transfer was only at 4% when the pigeon arrived. And it's just like, this thing's really slow. Like a pigeon can do faster for this sort of, this is it. This is exactly it. This is like for those sorts of volumes, data transfer is still really slow. So you just can't do it. You will not keep pace with the volume that is being created. I saw that one.
I love it.
COD working group.
This really brings it home.
4% of a 4 gigabyte data file had downloaded. Amazing.
Yeah, 4 gigabytes not even that big. Like, come on. Like, what the hell?
That is literally insane. But yeah, that's where we're stuck at, right? We're stuck on hardware and we don't realize that we're still running with cables under the ground. And don't try doing this in Australia either. No.
Yeah.
But no, that's great. And I think one of the reasons that Filecoin was born as well, if I'm allowed to do some speaking here, since we are on the Filecoin channel. But the point is to decentralize all this so you can do it all in one place, or also an interesting thing to think about when we're talking about hardware as well, is even the big providers are mostly concentrated in North America or Europe, a couple of places in the world, really. It's not a very distributed geography of data centers, even owned by these big, massive cloud providers. So, you're also kind of disadvantaging people in general in a more global world, and that does lead to issues. We've seen that the internet tried to, did a lot to change that as well. Like people can get an education with an internet, but even now, like that's not everywhere. So, I don't know what I'm on about, but definitely a point in there somewhere.
Just to sort of, get back to the case study. So the last part, let's say, okay, I set up my private network, and then I can run my, federated machine learning on there as well, and get all these amazing results. But so in terms of Lilypad and being able to then get royalties, can you sort of talk a little bit around that? How it would work for end users?
Yeah, so that's a really interesting point. I think, it's one that AI is bringing up a lot these days. Well, one of the things that, is kind of coming to the surface because of AI, like, how do we attest to, one, the originality of potentially any creative endeavor these days? Blogs, code, whatever it is. Was it actually written by a human? Was it actually done by a human? Is it actually your prime minister saying that? Who knows? Like, these deep fakes are going to be literally everywhere. So that's one problem. And the other problem is we've trained off all these data sets as well. And this is what you're mentioning as well here, Kartika. We've trained off all these data sets, and we don't really know where those data sets came from. Because a lot of this is a black box, a closed black box of information these days. I mean, we can have a guess where these data sets came from, but anyway, but the original artists or the original creators aren't getting any attributions here. So how do we manage to do that? And look, I do work in the Web3 space, and I think, this is exactly what blockchains are for. These are the kind of things that blockchain can help with. One of them is verification and attestation. Another one's a provenance record, and the other one is a payments layer. And we've kind of done something similar to that with a project called waterlily.ai, which trains a model on an artist's work, so fine tunes really to an artist's work. So this artist would upload, say, 50 images or so, and then we run this machine learning fine tuning model on it to fine tune to that particular artist's style. So it works best for artists that have a unique style. If they have stuff everywhere, it's a bit harder to train on, clearly. And then a user can come along and pay a certain amount to have an image created out of a prompt they put in. Like, my favorite one is a rainbow unicorn in space. This is one I use all the time, which is why you'll see unicorns everywhere. And then in the background, there's smart contracts here that automatically pay out to that artist. So the idea is that artist deserves some attribution for the original, data that they provided to this AI model. So that's one way blockchain could help with that, and that's just a proof of concept project. Like, I really hope people extend and expand on these kind of ideas for where blockchain can kind of help with offset some of the maybe more problematic areas of AI. And I definitely think verification or provenance and attribution are some of those. So, and yeah, under the hood, Lilypad runs this, and Bacalhau initially as well, but we're moving it over to Lilypad.
Amazing. So in theory, then, you could have like a group of, let's say, and in this instance, it's just one artist who gets the royalties back. But let's say there are like hundreds of people who, part of this, maybe a data trust or something else. And then by giving, like all this data, rather than, like currently people sort of give data for free, like even not knowing, right? But it would be much more conscious, like a conscious way of contributing data to like a sort of controlled or a good cause, but then you get like your little royalties back.
Yeah. 100%. I think, that is kind of something that's happening in the traditional tech space. People are going, okay, we want to have these public good data sets that people can train AI models on. Clearly, AI is going to make a massive difference in the world. There's problems it's going to solve that we wouldn't be able to solve on our own, like complex problems. It's going to speed up the time to solve some of these problems. And we were talking medically before. That's probably one of the spaces, and in science as well. So if we have these kind of open data sets that anyone can use, and for example, I know there's a lot of climate data on Filecoin. Imagine if you had next to that then something that could process that data, like Bacalhau, like Lilypad, something that can access and use that data in that same data house. And you can run that as an open source as part of your open source model, or you can run, these Python scripts or whatever it is, your own scripts, clearly, that are better than mine. Although you've got JavaScript now, so maybe, to try out some new things on top of this data. And if you've got and this is what the whole open source movement was about, wasn't it? Like, this is speeding up the process to come up with solutions. And a really interesting article actually that I read around this was this like leaked Google document about how Google has no moat and neither does OpenAI. And it was talking all about how open source is basically eating their lunch. They can do it quicker, they can do it better, and they can do it more targeted. These open source developers with the access to data and GPUs. So let's give it to them. Let's see what we get out of it. So yeah, that's my little spiel right there.
Yeah, you've done your open source advocacy for the day.
but I really believe it. So
yeah.
Get me started. I'm like, yes, this is how it should be, everyone.
I think the interesting, I guess the way in which it comes back into the federated stuff is having, like, it's one thing to have an open data set that is, like, built in an open source way or built by a community in an open way. In the medical case, obviously, like, it's more challenging to do that. And maybe you could have some medical data sets that were anonymized, but it's really hard to know whether or not that will be good enough before you release stuff into the open. Because even if you have anonymized data, if you have, it only takes like 3 data sets which contain the same individuals with some very specific properties before you can take 3 data sets that are anonymized and actually uniquely identify an individual in those data sets. So, like, if you're a data custodian for some of the sensitive data, it's quite, the bar for being able to release it publicly is very high. I mean, I don't know whether you've seen the news in the UK about a massive data breach that's happened with all the police data. Basically, they accidentally released all of the data of all currently serving police officers in the United Kingdom, including Northern Ireland, where police officers are, like, routinely in danger as part of their duty. And it's that sort of story that really puts people who are in a difficult position of being responsible for sensitive data, makes them, pushes them back towards being very data fearing, which is, like, the term that people use for, this is, maybe this is the one, or, this is another one. Brilliant. Another huge data breach. But no, like, it was details of all police. And I think the way it happened, by the way, was, I think people had all the data in Excel and didn't realize that if you delete the tab, but you still have a pivot table that references the data, and the data is still in the file. So they released the Excel with the pivot table, and then they didn't realize that all the data was still there. That's how it happens. So yeah, wow. This is what we're dealing with. So I think what's interesting, I think an interesting angle is, how do you do that sort of open work across data that is closed? And I've got one of the slides there from the Computer Over Data Summit, which was, so the term that people seem to be using to talk about this sort of stuff is compute islands. And the idea basically is it's topic specific compute, or gating access. So in the use case that you talked about, like your father, who's like an epidemiologist, has some data, has done some data collection. That was an expensive process, and would like to make that data more available for use, right? Like, ultimately, you're furthering science. So making that data as available as possible is a positive thing. But also doesn't want to be involved particularly with like moderating requests, or like spinning up Bacalhau nodes, or like doing any of the tech, because that's not the scientist's wheelhouse, right? Like, they should do what they do best. And so the idea here is that people will contribute their data sets, or people will contribute their compute hours, but not in a way that actually removes the data from their control. So it's still within their domain, or within their kind of enterprise, boundary. But then they put their trust in an external moderator who is kind of well chosen to allow or deny access based on their policy. So, like, your father might say, I only want this data to be used to further medical science. I don't want it to be used to develop, like, private drugs, or I don't want it to be used to kind of train AI models. That's my ethical stance. And so it'd be up to the moderator to kind of apply that policy. And because you've got that whole end-to-end thing there, if you introduce that remuneration element where the user on the right is paying to get access to that data, then that can correctly flow back into the coffers of the university to fund more science, more data collection, right? So this is, yeah, you use the word data trusts, absolutely a big thing. At the moment, data trusts are very much a kind of social or legal construct, right? So like they're not on a very strong technical footing, and mostly they do involve basically a bunch of companies or a bunch of organizations that don't have a huge desire to share data with each other than under specific circumstances, ultimately giving their data up. And some of the computer over data technology is able to say, in fact, if we go back a slide, perhaps, yeah, is able to say, you don't have to give your data up anymore. So the risk is much smaller, but you will make it available on a computer over data network for querying. And the person who's going to be moderating or doing the querying is someone that you trust. So someone from your industry body, or like maybe if it's a government organization, if you're a state health organization, it's your federal government body, someone that you ultimately do have a level of trust in to use that data appropriately. And then obviously subsequently what you can do, because this is computer over data, you can say, oh, actually, what did they do with my data? What queries have they run? And you can look through it and say, oh, actually, that wasn't really what I had in mind. I'm going to end this relationship. Whereas if you hand over your data, obviously you no longer have visibility of what people are doing with it. So yeah, I definitely think there is a way to bring more of that private data in a safe way to good use in like training models that have public benefit, or like doing other science that has public benefit, right?
Yeah, this is awesome.
Absolutely. Like I think in terms of if you when you think about where the data and how AI models have been trained so far, and the bias of it, and it's just crazy, right? So if we could enhance and have like these really reviewed data sets that have like like a bias checker or whatever, so what you're like actually looking for, and I completely understand, like people just if you want to train your model, you just need to get started, so you go the easiest route, but then at least what what the holes are, like where you need to sort of like add to it, and there will be different pockets of that's how I envision it, like different pockets of people, or different groups of people who can then sort of like supplement it, like support each other within that, but still get like a monetary reward at the end. Like I think that would be like sort of an ideal world.
Yeah, definitely. And I do think there's something really powerful in people being able to be part of it without having to do it all themselves. Like, in this case, the scientists or the state clinicians who are able to contribute stuff and see some of that reward without having to run the whole system, build the technology from scratch. And I think that's what computer over data in general almost has a responsibility to do, or like part of the vision of the whole movement in general is bringing more of this tech, which is not new, let's be clear, like they were doing this in the 60s, right? But bringing more of this tech to more people through all the stuff that we've learned like over the past decades, right? And like exactly like you say, building it in a way that allows people to take part no matter where they are, and be compensated for that.
Amazing.
Amazing. I've learned a lot today.
Right?
Yeah.
I mean, I'm off to contribute to science, to be honest. I've got things to do. No, it's been really great talking to you, Simon. I think it's probably a good place to leave off here, unless you have any further comments, Kartika, or...
Yeah, well, I've got 1,000 more questions, but I'll save it for another time.
Well, thank you very much, Simon, for joining us today. I really appreciate you being here, and it taught me a lot. I am off to go, help make the world a better place after that little spiel. So thank you.
Thank you both for having me.
Thank you, everyone.
You're welcome.
Bye.
Bye.
Bye.